Hi everyone, so for this lesson, we are going to continue with minimum spanning tree. So in your handout, we can write lesson B and we can put 9th of January. Okay, then next let's look at the page 137. Okay, sorry, it's supposed to be 117 in your book. Okay, all right, so we are going to continue for the part for minimum spanning tree, but then instead of looking at minimum spanning tree in terms of a graph, then we are going to look at it in terms of distance table. So that's why you will realize that the learning outcome is exactly the same here. So that's why we wouldn't like go through them again. Okay, but just make sure that before you continue with this lesson, then you must make sure that you are already familiar with the prims and Kruskal that we discussed in the previous lesson. Okay, so just a very quick recap or a quick summary for the thing that we have learned in the previous lesson. Okay, so for what a minimum spanning tree is, so for a given connected weighted graph, minimum spanning tree is the spanning tree which is a subgraph of a graph. Okay, and also you must make sure that all the vertices are connected and there is no cycle. Okay, so minimum spanning tree is basically a spanning tree with a minimum total weight. So that's what we learned in the previous lesson. Excuse me. Okay, so there are two algorithms that we have learned so far. The first one is what we call as Prim's algorithm. Okay, so it's a method of choosing the vertices, right? So you start from any vertex, then after that you are looking at all the neighbors, then find out which is the neighbor that giving you the nearest distance. Then the second one, we have Kruskal algorithm. So for Kruskal algorithms wise, what do you need to do is you are looking at all the edges of the diagram. Then after that, you find out the shortest edge. Then you continue with the next shortest edge until you get all the vertices connected in your spanning tree, and you must make sure that you don't create any cycle. Okay, so by now, these are the two algorithms that you should be very familiar of. Okay, so for this lesson, we are going to talk about distance table. So what is the difference between today's lesson and also the previous lesson is that previously we determined the minimum spanning tree, which the information is displayed in a network. Okay, or you can also say display in a graph. Okay, so basically, like for example, you are giving the diagram, right? Then after that, you just apply Prim's or Kruskal in order for you to find the minimum spanning tree. But in some of the cases, the network involved can be like very large, like what I mentioned previously. Like if let's say you can have 100 vertices, then 200 of edges. Okay, so that's why it wouldn't be very easy if let's say you show everything in a graph. So that's why the information may be clearer when we try to show it in a more organized way, which is by using the distance table. Okay, so in this case, because the information is shown by using a distance table, so that's why it is important for us to know how to identify the minimum spanning tree from the distance table as well. Okay, so we just recall a bit for the step for the Prim's algorithm, because for distance table, we are going to do the same thing. The idea is actually the same thing like how we carry out Prim's algorithm, but it's just that instead of doing in a graph, we are doing it on a distance table. Okay, so for Prim's algorithm, what we were doing is we choose any vertex to start, right? Okay, so then we are looking at all the neighbor, which means all the adjacent vertices. Then we find out the vertex that give us the smallest weight, okay, like the least distance. And when we are doing that, we always make sure that there's no cycle is introduced. Then after that, you keep on looking at the neighbor for all the vertices that is already involved until you repeat it until all the vertices are included in the spanning tree. So this is what we have done in Prim's algorithm. Okay, so we are going to apply this entire set and put it in a distance table. Okay, so the method that we are using here are based on Prim's algorithm as well, but it's just that it's in a form of distance table. Okay, so later when we are applying the Prim's algorithm in the distance table, I will also Sorry for that. I'll also explain it by using the diagram so you are able to relate like whatever that you are doing now is exactly the same with whatever that you are doing in the previous lesson. Okay, so for distance table, it's going to be slightly confusing because of the steps that you are doing, right? It's a cycle kind of thing. So you must make sure that you don't stop halfway and you don't skip the step. Okay, I repeat one more time. It's very important for this chapter, like whatever that you are doing, you make sure that you are doing it carefully and make sure you don't skip any step. Okay, because as you skip any step, you are putting yourself into the risk where you will be committing mistake. Okay, so do make sure that you be very careful and also don't skip the step. Okay, so the step one is that we will choose any vertex within the network as a starting point and draw an arrow. Okay, so that's why the first word that I highlight here is arrow. So that's why you can imagine that the situation is like arrow. Okay, so this is where you start out. So that's why you start from here. Okay, that's the first one. Okay, then after that, what you need to do is that to make sure that there's no cycle is repeated, then we need to strike through. So that's why after you do the arrow, then the second thing that you need to do is to strike through the entire row. Okay, so after you have struck through it, then among the adjacent vertices, find the vertex with the smallest weights and you circle it. So that's why the next highlighted word here is circle. Okay, and what do you need to do is you repeat all the steps until all the rows are crossed. So repeat it, so which means go back to arrow. Okay, so that's why it's important for you to not skip any step or else you will be having some mistake when you move when you reach your answer. Okay, so let's try it out. What does that mean? Okay, for example, if let's say you are looking at a diagram, right, isn't it from what you can recall previously, you will actually start off, for example, if I choose to start from A. So this is where you choose A, then you look at the neighbor. Am I right? So this is Prim's algorithm in diagram. So it's the same thing as well for distance table. Okay, sorry. Before that, maybe let me explain a bit for what a distance table is. So this is basically a distance table. So in some of the situation, the question wouldn't give you this diagram, but they only give you this table, and you need to solve minimum spanning tree according to that. Okay, so this distance table is exactly the same thing like what you have learned in adjacency matrix. Okay, for example, from A to B, you can see 11. From B to A, you can see 11 as well, right? So that's why this is symmetrical about the leading diagonal for all the value. So that's why you can see 11. So A to C, you have 12. So that's why A to C, you got 12. C to A, you also have 12. So A is only adjacent to B and C, so that's why B and C. So for example, D is adjacent to C, E, G, F. So that's why D, you have C, E, G, F. Okay, so this is what a distance table tell you. All right, so what we need to do is the same thing. You can choose anywhere that you want to start. Okay, it's not necessary has to be A. So you can start with any place that you want to go with. Okay, for example, let's try out a different thing now. Okay, let's say we start from donkey. Okay, so what I will need to do here is that it's the same thing as when I pick my vertex in the diagram. So I'm going to pick where I want to start in the distance diagram. So I need to start from arrow. So I start with D. So I put an arrow at D and I strike through the entire row for D. Okay, the reason that we are doing this is that I want to make sure that since D is already involved, I want to make sure that I don't go back to D anymore. You remember, because if I go back to D, then which means that I'm able to find out a cycle, because only cycle allows us to go back to the vertex. Okay, so that's why arrow at D, second step strike, okay, then after that circle. Okay, what is that meant by circle? So you are going to look at the column that you have put down your arrow. So for now, this is the only column that you have arrow. So this is the only column that you need to look at. So which means, for example, now you already have 4 arrows, then you need to look at 4 columns. Okay, so now only 1 arrow, so there's only 1 column that you need to look at. So look at all the number and choose the number that give you the smallest value. So in this right? So that's why we circle at 7. Is that okay? So the idea is the same thing as in your diagram, right? You are looking at, you see 8, 12, 7, 16. So that's why 8, 12, 7, 16. Then you are picking the smallest one, right? So that's why F, then you are choosing the 7. Is that okay? All right, so after you circle, then you need to go back to arrow, right? So what is that meant by arrow? So you circle 7, meaning that now you already involve F. So F is included, so that's why arrow at F, and I want to make sure I don't go back to F anymore, so that's why I strike through F. Okay, so that's why you see after I circle, I put an arrow. After I put an arrow at F, I strike through the entire line for F. Is that okay? All right, so after I do that, then after I strike through, then I need to go back to circle, right? So remember what I mentioned just now, you need to look at all the column that you have already put in your arrow. So it's the same thing like when you're looking at this, then you need to look at both D and F, right? So to look at all the neighbor. So that's why you can realize 8, 12, 8, 16, 21. So you can see that it's the same thing. So 16, 8, 12, 21, and 8. Okay, so you need to look at both of these rows, then you pick the number that is the smallest one. So you have two smallest, which is 8 and 8. So it doesn't matter, it's up to you like which one you want to choose. Okay, so because of due to whatever that you circle first, your answer for your distance graph can be different than your friend. But at the end of the day, when you are putting it in a distance diagram, then you are, onto a graph, then actually the answer is the same. Okay, but it's just that your distance table, your working might look different, but at the end of the day, your result is the same. Okay, so after you strike through, then we go on to circle, right? So 16, 8, 12, 21, 8. Okay, let's say I choose the 8 here. So this 8 allow me to go to E. So that's why arrow at E, then I strike the entire thing for E. So it's the same thing like when I choose all the number, then I choose to go to E. And I try to delete everything for E because I don't want to create a cycle that go to E. Is that okay? So I strike through everything at E already. So the next one is strike, then circle, right? So circle, which means that now there are 3 columns that I will need to look at, all the D, all the E, and all the F. So you realize that there's 1, 2, 3, 4, 5, 6, 7. So when you look at this, you will see 7 as well. So like 1, 2, 3, 4, 5, 6, 7. Is that okay? So it's the same thing like the Prim's algorithm in your diagram. Okay, so among all these numbers, so you can see that the smallest number among 16, 12, 22, 10, 10, 21, and 8, the next one is 8, right? So that's why we are going to circle 8. And this 8 brings us to G. So arrow at G, then I strike through the entire G. Okay, so now as we move on, there are 4 columns that we need to look at, right? So D, E, F, and also G. So that's why 16, 22, 21, 10, 9, and 7. And the smallest number is 7. So that's why circle 7. 7 brings us to I. Arrow at I. Strike through the entire thing for I. Okay. So now we have 5 arrows, so that's why we need to look at all the 5 columns. Okay, so for D, we left with 16, E, we got 22 and 10, F, we got 21, G, we have 9, and I, we have 10. So among all this value in the column, the smallest number is 9. So that's why circle 9. 9 bring us to H, so arrow at H, then you strike through the entire thing for H. Okay, so now these are the 6 columns that we have already included, and now the choices are from 16, 22, and 21, because all the other they are strike through already, right? So 16, 22, and 21, and the smallest is 16. So 16 bring us to C. So arrow at C, strike through the entire C. Okay, so now the columns left that we can look at is all of these you don't have any choices, right? So which means that you are comparing among 12, 7, and 22. So the smallest number is 7. 7 bring us to B, arrow at B, strike through B. Okay, and now you realize that for the last number that you are comparing, because all these are crossed already, so only 11 and 12, and the smallest number is 11. 11 bring us to A, so arrow at A, then you strike through the entire thing at A. Okay, so you see, right, because of you are circling this, then after that strike through, right? So your step will end when all the rows are strike off. Okay, so that's why you can see that the entire A is strike off, then all your rows, they are already strike off, then that's the end for your algorithm. Okay, so before we move on to the answer, then I want you to realize something. So it's the same thing now. In your table, right, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 vertices, right? So that's why it means that you should only have 8 circles because 9 vertices should give you 8 edges. So 1, 2, 3, 4, 5, 6, 7, 8. So that's why it's correct. Okay, and something that you should realize is that for there should be one of the row which is crossed entirely without any circle. I repeat one more time. You should always have a row that is strike entirely without any circle because that is where you start. You remember when we start, then we put an arrow, then we strike off the whole thing, then we only choose the circle, right? So that's why when you start, you should have one row with all the numbers are strike off. Okay, and for every row, you will be having one circle. Okay, this is definitely. So you have 9 row, right? So one row, entire thing is strike off. Then all the other, then you have one circle for each row. But for each of the column, it's not necessary. It depends on your answer. Okay, so that's how you can check whether or not your answer is right or wrong. Okay, so after we have finished this part, then now we are going to put the answer inside the diagram. Okay, so AB, then meaning that AB 11. So this is the one that you choose. Okay, so 7 is between B and C, so that's why between B and C. So C to D, you have 16, so C to D, you have 16. Okay, then after that, continue. E to D, you have 8, so E to D, we have 8, so just now I already highlight. Okay, so F to D, we have 7, so F to D, 7. Okay, then G to F, we have 8, so G to F, we have 8. Okay, next one is H to G, we have 9. H to G, we have 9. And then the last one is I to G, we have 7. So I to G, we have 7. So you should be able to realize that this diagram that you are getting is exactly the same diagram that you get in the previous question. Okay, it's exactly the same question. The only thing is we are doing it in a distance diagram for now. Okay, so that's why if let's say you are you can remember the previous answer is supposed to be 73, okay, but we're just writing down. So it means you can add up all the number that you have circled. So 11 plus 7 plus 16 plus 8 plus 7 plus 8 plus 9 plus 7, and that's where you have 73. All right, so that's how you are doing this question. Okay, so the same thing like the notes here, like what I say, the number of edges supposed to be 1 less than the number of vertices. Okay, so I will do one more time again in the next example. Then after that, question 4, you should be able to do it yourself before we move on. Okay, so this is the question which is the same with your example for this question. Okay, so we are going to do it in distance table now. Okay, so yeah, what I mean is in a real exam, so that could be a situation that they give you a distance table, then it's an empty graph, then you need to just draw the minimum spanning tree. Okay, so which means that there are situations that they won't give you both, so you cannot rely on this diagram and you ignore the distance table at all. Okay. All right, so yeah, this question is a previous example where we are talking about the vertices here represent the buildings in a university, and also they want to make sure that they are putting on like cover some of the part so that the students will be able to go through, go to any buildings when they are raining. Okay, but then they want to cut down the cost, so that's why they try to find out the minimum spanning tree. Okay, so for this question, okay, let's try it out. Okay, so in this situation, then we have, okay, so same thing, you can start anywhere. Okay, let's say I just simply choose one maybe. Okay, let's say we start from N1. Okay, let's say N1 is here. Okay, so we start from N1. So I wouldn't be referring to this diagram anymore. We should look at this diagram and we find out the answer. Okay, let me make it a bit smaller so that you can see the entire. Okay, all right, so we start from N1. Okay, so remember, arrow, strike, circle, arrow, strike, circle, arrow, strike, circle. Okay, arrow at N1, strike through the entire thing for N1. So look at the column that you have already put down the arrow, which is 200, 180, 190, 350, smallest 180. So circle 180, 180 bring us to N2, arrow at N2, strike through the entire N2. So there are two columns that you have put in the arrow now. So that's why you need to look at both N1 and N2. So 200, 190, 220, 350. The smallest one is 190. So 190 bring us to N3. So arrow at N3, strike through the entire thing for N3. Okay, so now you have three columns with arrow. So which is N1, N2, and N3, but N2 and N3 don't have any adjacent vertices anymore. So which means you can only pick from here. So the next smallest is 200. So circle 200, 200 bring us to C. So arrow at C, strike the entire thing for C. Okay, so now there are four columns that you need to look at, namely C, N1, N2, and also N3. So the numbers that you are comparing are 200, 350, 390, 190, 270, 400, and also 350. Okay, so out of all these values, the smallest one is 190. So circle 190, 190 bring us to S1. So arrow at S1, then you strike through the entire thing for S1. Okay, yeah, feel free to just pause the video whenever you realize I'm too quick or what, okay, because it's on your own. I mean, or even you can just stop the entire thing and you just watch the entire thing first, then after that you watch it again and put down your answer, okay? So we already go to S1 and we strike through everything at S1 already. So now there are 5 rows that you need to look at, namely all the thing for C, everything for S1, everything for N1, everything for N2 and N3. Okay, so which means you are comparing 350, 390, 270, 400, 400, 200, 180, and 350. So the smallest number is 180. So 180 will be able to bring us to S3. So that's why arrow at S3, then you strike through everything for S3. Okay, so now you should be comparing everything in C, in S1, in S2, N1, N2, and N3. And the smallest number that you can get is 190. So circle 190. 190 bring us to S2. So arrow at S2, then you strike through everything for S2. Okay, so now same thing, you are comparing column C, S1, the entire thing until N3. Okay, so which means the number that you are looking at is 350, 400, 350, 390, 270, and 400. So the smallest number is 270. So 270 bring us to E1. So that's why arrow at E1, strike through everything for E1. Okay, so same thing, you look at everything for C and everything from S1 up to E1. So all the smallest number that you can get, you are comparing 350, 390, 400, 400, and also 180. So the smallest number is 180. 180 bring us to E2. So arrow at E2, then you strike through the entire thing for E2. Okay, so now you are checking. So all of these, they are already strike through. So that's why you are just comparing 1, 2, 3. Okay, 350, 390 versus 400, because all these, they are not, you don't have any edges between the vertices. So that's why the smallest is 350. 350 bring us to W1. So arrow at W1, then I strike through the entire thing for W1. So comparing these two numbers, smallest number 180, 180 bring us to W2 and you strike through the entire thing for W2. Okay, so you will realize that as you strike off the last row, then you should be able to have all the arrow at the top already. Okay, so this is where the answer is. So same thing, double check. There's one row with the entire row is checked off. Then after that, each of your row, you have one circle. All right, so after you have done that, then now we can put in the answer into the diagram. So the first one, we have 200 in between C and N1. Okay, in between C and N1. In between W1 and C, W1 and C. Okay, in between W2 and W1, W2 and W1. Okay, then 190 between C and S1, between C and S1. Okay, next one, 190 between S2 and S3, between S2 and S3, 190. Okay, 180 between S3 and S1, 180 between S3 and S1. Okay, so next one, N2 and N2 and N1, N2 and N1. Okay, and then N3 and N1, N3 and N1. Okay, 270 between C and E1, between C and E1. Okay, then after that, E2 and E1. Okay, so that's your answer. So you can see that there's no cycle created and you have already involved all the vertices here. Okay, and you should realize that this answer should be the same answer with the one that you got here. Okay, so the same thing, we are going to write down all the numbers that are involved. Okay, so we have 200, okay, plus 350, okay, plus 180, 190, 190, 180, 180, 190, 270, and also 180. Okay, so from that, then you should be able to get 2110 meter, which is exactly the same thing as the previous one. Okay, all right. So now we are in the last example here, which this diagram is the exactly same thing like this diagram. Okay, but you need to do it in terms of distance table. Okay, all right. So now same thing. Please pause the video and you try it out yourself first before you look at the answer. All right, so we'll go through a quick discussion here. Okay, so of course, I just want to remind you again, your distance table might be different than my distance table later because it will be based on where you start. Okay, so that's why no worries if let's say you didn't get the same circle as mine, but then at the end of the day, if let's say the diagram that you are getting right is the same thing as the previous answer, then you know that you are correct already. Okay, but make sure that you are able to get the answer because or else then you can, if let's say you still need one more time of guidance, then you can still try to look at this discussion again. Okay, all right, so same thing, we are going to start from anywhere. So let's say I'm just going to follow the sequence here. Let's say I'm going to start from P. Okay, so arrow at P, look at the, arrow at P, strike through P. So remember, arrow, strike through, find out the smallest number, circle. So circle bring us to S2, arrow S2, strike through S2. Look at everything that we have already put the arrow, so which means including all this column and all the column here. So the smallest number is 7. 7 bring us to S1, arrow at S1, strike through the entire thing for S1. Okay, so among all these numbers, then these are the number that we are comparing with 18 and also 8 because these are all the columns with arrow. So next smallest number is 8. 8 bring us to S3, arrow at S3, strike off everything for S3. Then after that, yeah, so because all these are already strike off, so basically you are comparing this bunch, okay? So all this number with 18 and also 9. Smallest number is 9. 9 bring us to S4, so arrow at S4, strike through everything for S4. Okay, so comparing 16, 11, 17, 16, 18, and also 19, smallest number 11. 11 brings us to S6. So arrow at S6, then after that, strike off everything for S6. So you are comparing 16, 17, 16, 18, 19, and also 9 and 10 here. Okay, so everything that you have put in the arrow, you need to compare. So among all these numbers, smallest number is 9. So 9 brings us to S5, arrow at S5, strike through the entire thing for S5. Okay, then after that, all these numbers are the one that we are comparing. So yeah, because these are all the one that having arrow. So 10. So 10 brings us to S7. Then after that, strike through everything for S7. Then the next smallest number is 8. So 8 brings us to S8. So S8, then strike the entire thing. Okay, so same thing. After you get the answer, remember to check that 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 vertices. So that's why you should have 8 circle. So one of your rows supposed to be all strike off. Then after that, you have 8 circle. So one for each of the row. Okay. So after you finish it, then let's just put in our answer in the diagram to check whether it's correct or not. So 7 between S1 and S2, 10 between S2 and P, 8 between S2 and S3. Okay, then after that we have 9 between S4 and S3. And then next one is 9 between S5 and S6. Excuse me. Okay, so P to S6, 11. 10, S7, and S6. Okay, and then we have 8 between S8 and S7. Okay, so this answer is exactly the same thing as what you have gotten previously. Okay, so now same thing, you can add on all the number. So we have 7 plus 10 plus 8 plus 9 plus 9 plus 11 plus 10 plus 8. Okay, so that's why 17, 25, 34, 43, 54, 64, or 72. Okay, so this is correct. Okay, all right, so that's it for the distance table. It's actually quite straightforward. The thing is just to make sure that when you are doing it yourself, don't skip the step and be very careful, then you should be all right. Okay, so that's the idea for this thing. So same thing, spend time for your homework. If let's say there's any question, feel free to just text me. Okay, all right, so yeah, all the best for your test and I'll see you next week.